Hey guys, welcome to today's video. In this video, we are going to solve one more Leetcode question, which is question number 105. Construct binary tree from the preorder and the inorder traversal. So it comes on a medium. So let's understand this question first. So given two integer arrays preorder and inorder, where preorder is the preorder traversal of the binary tree and inorder is the inorder traversal of the same binary tree, we need to construct the binary tree. So if you remember, like preorder means like you traversed the root of the node first, and then left side of the tree, and then right side of the tree. And in order, you traverse the left side of the tree, then the root, and then the right part of the tree. Okay, so these traversal have been given. So if you see the preorder, like you need to traverse the root first, which is 3. So 3 is already here. Then the left side of the node, then it is 9, which is given here, and then the right part of the tree. So in the right also, we need to traverse the root first, which is 20, and then the left, which is 15, and 7, which is the right part of the tree. So our preorder traversal is given. Similarly, the inorder traversal is also given. Like you traverse first the left part of the tree, which is 9. So 9 is given. Then the root, which is 3. 3 is given, and then the right part of the tree. Okay, and from the right part also, it's like 15 is the left, root is 20, and 7 is the right part of the tree. So our true traversal has been given, and we need to construct this binary tree. Okay, so first we need to understand that what is the need of preorder and inorder traversal to solve this question. Okay, the first and the foremost thing is that like preorder means like you traverse the root of the tree first, and then the left, and then the right, correct? And in the inorder, you traverse the left part of the tree, then the root, and then the right part of the tree. So if you see preorder traversal, you know the first one is the root, correct? So you know 3 is the root, so we can create 3 as the root part of the tree, right? Now our second difficulty is how we will come to know about the left and right part of the tree, right? So in this case, my inorder traversal is gonna help. So we know that if the middle one is the root, then left part is then the left side of the tree is the left part, and the right side of the tree is the right part. So if you see 3, if I made 3 as a root, my 3 is here. Okay, so this part will become my left, so which is like 9, and this part will become my right part of the tree, which is like 15, 20, and 7. Okay, so that's how like preorder and inorder traversal are gonna help us. Okay, now if you see, so now I have got 9. Okay, so 9, if I make 9 as a root, then we need to get the left side and the right side of the 9, right? So if you see, if I make this 9, then in left side nothing is there, right? And in the right side we have already traversed this 3, so we will not have anything over here. So this our 9 becomes the node, and we connect this to our 3. Now if you come to 15, 20, and 7, so in this, now how we will decide which one will be the root? So we will take the help of preorder traversal again. So our 3 is done, 9 is done, now 20. So we will make 20 as our root. Okay, now we need to make sure like what will be the left side and what will be our right side of the node. Okay, so in this case, what is going to happen? So if you see over here, my 20 is here, so my left side will become 15, and 7 will become our right. So that's how we created our tree. So our 3 become here, then 9, then 20, then here it become 15, and it becomes 7. So that's how we created our binary tree. So this is what is the original one it is given. Okay, so whatever we have spoken like this, we will create the same in the code. Okay, so let's go back to code. So let's write the code for this. So we need to build the tree. So for this, what we are going to have, we are going to have a pointer which will point my preorder indexes. So I am taking P as that particular index. So to get the elements over here, like 3, so when I made 3 as my root, so I need to get the index of the 3 over here, so that I can take like left side of this particular array is like the left side of the tree, and from this index to this index will become our right side of the tree, right? So we need to know the value, like where my 3 is in this in order traversal. So we need to know the indexes of all these. Okay, so for this we will use a map to keep the indexes. Okay, now we are taking one utility variable which will give me the in order length. Okay, now we need to populate the map. We are going to create a for loop I less than n and I plus plus. Okay, minus map dot put in order of I and its index. Okay, so our map is constructed and we need to return. I'll create a one more build tree overloaded method where I'm going to pass this preorder, in order, my map, starting index, ending index, and my the length of this array. Okay, so I have to create one more method. We can make it private. Okay, so we are going to add in order map int start index, int end index, and int n. Okay, now we can add it over here. Let's format it. Okay, now first what we will do, so if my pre-order index become greater than equal to n, so we need to return the null. Okay, so like pre-order, when we will take this pre-order for knowing the root. So if it passed the particular indexes, then we need to return the null, right? So it's a base case. And if our start become equal to end, then also we need to return null. Okay, now this is like 3 lines of code. We need to create a object of tree node, and we need to pass the pre-order because we are going to take the root from the pre-order, right? And we are going to p plus plus. We have created the node. Now node dot left will be the recursive one, so we need to build the tree. We need to pass pre-order, we can pass in order, map, these all things are same. Now we need to pass the start index. So start index remains the same, and end index will be before my this p, right? So we need to know the index of that. So what we will do, map dot get node dot val, because we already put that data in the node and then we did the p plus plus, or else you could have done pre-order of p and then you would have done p plus plus. That's the same thing. So since we have already created the node, we are taking the help of this node value. Okay, so we have added the end index and n remains the constant. Similarly for the right side, so right side we are going to create recursive build tree. We are going to pass the same these 3 parameters. Now for the start index will be, so after this whatever the index will be there, that, right? So we are going to pass the indexes, map dot get node dot val. You can retrieve it once and use it again. So and n remains the same, and n. Okay, and we simply return the node. So it's the same thing what we spoke about. So that's the same set of things what we have done over here. Okay, let's try to run this. So our test case got passed. Let's try to submit this. So yeah, it got passed. So hope you understood this question. Okay, see you in the next. Thank you.